Hi everyone, we're starting our new unit on linear and exponential relationships. We're going to be looking at chapters 5, 7, and 14 in the MYP 5 Plus textbook. And we're going to start with the first chapter on coordinate geometry. We should go through this quite quickly since you have done this in the past. But there are certain things that we will be taking a look at that you haven't seen yet. So, alright, so we're going to start with section 5a, where we're going to be looking at the distance formula. So the distance formula allows us to find the length of a segment, whether it is a horizontal line, as shown in the first diagram here, or a vertical line, or if it's placed on the xy coordinate plane as a diagonal. Now, if we were looking for the length of a horizontal line, so on the horizontal, with the horizontal line, what we would do normally is we would probably be able to read off of the graph, just counting the number of squares horizontally. You could just count them off and see what the distance of the segment is. However, because our graph does not correspond to the actual values of the number of boxes, then we're going to disregard that, and we're going to do it algebraically. Okay, so let's take a look algebraically. Now, because what is changing here are the values of the x, then that means that our values of the y remain constant, and so we're going to be dealing only with the change in the x values. So we're looking at the change in x values. Okay, so our change in the x values are going to go from -3 to 4. Now, the change in the x values, so it's going to be change in x's. So we can do that as taking the absolute value and the difference of the absolute value of the coordinates that are given. So the example here could be that I would take the difference between this value x and this value x, and I could call this x sub 1 y sub 1, and I could call this x sub 2 y sub 2. Okay, and I would say, taking the absolute value of x sub 1 minus x sub 2, or I could say x is equal to the change in the x's, or the length of the segment AB, is going to equal the change in x sub 2 minus x sub 1. The fact that we have the absolute value is going to make sure that we don't get any negative values as our length, because we can't have negative values. So I would say x sub 1, I'll call this x sub 1, so it'll be -3 minus 4, taking the absolute value of that, which will give us, in the end, the absolute value of -7, which, when we remove the -7 from the absolute value sign, it will come out as a positive. So it would be 7 units. Likewise, if I took it from the other side where I said x sub 2 minus x sub 1, it would just be 4, the absolute value of 4 minus -3, which would equal the absolute value of 7, which is equal to still 7 units when I take it out of the absolute value sign. Now, that would be if we were looking at horizontal changes. So we were looking at a horizontal line. Now, if we're looking at the vertical line, so a vertical line has its changes not with the x, but it has the changes with the y. So it's our y values that change in the vertical. So when we look at the vertical line, it's going to be changes in y value, in y values. Okay, and again, the change in y value then would be the change in y sub 1 minus y sub 2, the absolute value of that, or it could be the change in y sub 2 minus y sub 1. So either or, as long as we have the absolute value sign, it shouldn't cause any problems. So that the length of AB could be 2, and I'll call this x1 y1, and this is still x2 y2, and I could say 2 minus -3 equals, and you take the absolute value of that, it equals the absolute value of 5, which equals 5, or I could take it as -3 minus 2, let's take the absolute value of -5, which tells me that the length is still 5 units. So either or, it's going to be 5 units, the vertical distance. So it's the change in the y's vertically, and when I'm looking for a horizontal line, it's the change in the x's. And we take the absolute value of both of them to make sure that we don't have any negative values for distances. Now, if we're dealing with a diagonal or a line that is neither horizontal nor vertical, then what we're going to do is we're going to take the horizontal distance, the change in the horizontal distance, and we're going to take the change in the vertical distance. And we'll do that and we'll find ourselves with a right angled triangle. So let's say that I've got my point here. I'm going to call this C. So my point should be found at 4 and 1, because horizontally the point goes up to 4, and vertically though it goes up to 1. So I know that my point here is 4, 1, so I'll call this x1, y1, I'll call this x2, y2, and I'll call that x3, y3 if we want, okay? And so I'm going to find my horizontal distance first. So my horizontal distance, which would be AC, so I'll say that AC, the horizontal distance, is going to be equal to 4 minus -2, which gives me the absolute value of 4 plus 2, which equals 6. So I know that the horizontal distance, I'll put that in green, is going to equal 6. And now I'm going to find my vertical distance. So the vertical distance is going to be BC, and I'll say that it's going to be a change in the y's. So it'll be 3 minus 1. So it could be 3 minus 1 is equal to the absolute value of 2, not 4. It's going to be the absolute value of 2, which is just going to be equal to 2. So I know that this distance is going to be vertically, it's going to be 2 units. Now, because we've formed this 90-degree triangle, technically to find out what the hypotenuse is, because what we are looking for is the hypotenuse, it's opposite the 90-degree angle, so that must be the hypotenuse. So all I'm going to do is I'm going to say then that using the Pythagorean theorem, I could say that c squared is equal to a squared plus b squared, and I could say that my hypotenuse squared is equal to one of the sides squared plus the other side squared, and it'll be the sum of those. So I'll have the square root, I'll have 36 plus 4, which gives me 40. And that means that the value of c would be equal to the square root of 40. And the square root of 40 is going to be approximately, if we put this in terms of simplification, it would be equal to 2 root 10. Okay, but in terms of a decimal, the root of 40 would be approximately 6 point something. Okay, so we know that it's 2 root 10, or it'll be 6 point something, and I'm not going to research what that is right now. I'm not going to look that up. Okay, so we have figured out, using the Pythagorean theorem, we have figured out what the diagonal distance of AB is going to be. Okay, and therefore AB is going to equal 2 root 10. All right, so what is it exactly that we found? What we actually found then was that by using the Pythagorean theorem, we figured out that the length of the diagonal is equal to 6 point something, or 2 root 10 in the previous question. Okay, so in this next question, we're going to do exactly the same thing. We're going to find out exactly the same thing here. I seem to have canceled one of the coordinates. Just a sec. Okay, so the point is going to be, the point is negative 5, 1 for A, and we've got B that's 3, 4, and now we need to figure out what the value of C is. Okay, so how do we figure out the value of C? We make a 90-degree triangle, and we see that that the vertical line goes to a maximum, the vertical line rather goes to, it hits here at 3 and 1. So that, how do we get that? Well, my horizontal and my vertical crossed, and I see that horizontally it must go to a 3, and that vertically along the y it must go to a maximum of 1. So 3, 1 has to be our point here. Alright, so let's find our value of the, let's find our horizontal distance between A and C. So our horizontal distance between A and C is going to equal the absolute value of negative 5 minus 3, which equals the absolute value of negative 8, which makes it 8. So I know that that distance is 8. And then I look at it vertically, and I know that it's my y values that are changing at BC. So my y values are going from 4 minus 1, which equals the absolute value of 3, which makes it 3. So I know that my distance is 3 vertically. Now, because I have a 90-degree triangle, what I'm going to do is I'm going to use the Pythagorean theorem, and I'm going to say, well, my AB squared is going to equal 8 squared plus 3 squared, so that it gives me 64 plus 9, which gives me 73. AB squared equals 73, and therefore AB is going to equal the square root of 73. And the square root of 73 is going to be approximately 8 point something. So it might be 8.2, 8.3, but it'll be 8 point something. So that's approximately our length. And it would make sense because remember that our hypotenuse must be the longest side since it is opposite the largest angle. Okay? All right. Now, how does this all get to a formula? Well, the formula that we're going to be learning with the distance, between 2 points is going to be this one. Distance is equal to the square root of the change in the x's, all squared, plus the change in the y's, all squared. Now this formula, this is the distance formula, this formula is nothing more than the Pythagorean theorem, except all I did was here is that I didn't take the square root right off, but I could have written AB, if we look back here, I could have written this as AB, and I could have taken the square root automatically from the beginning, okay, so that AB equals all of this, instead of taking AB squared. Now, let's take a look at another example with the formula. Okay, so instead of drawing a right angle triangle every time, we can use the distance formula. And the formula is really nothing more than the Pythagorean theorem that we used on the previous page. So we found the difference of the x's, and then that was our horizontal distance. And we found our distance on the y's, which was our vertical distance. And what did we do with that? We squared each one of them. So we squared the horizontal distance, we squared the vertical distance, and then we took the square root. We added those together and we took the square root. All right, let's try doing an example. All right, so our example here is find the distance between these 2 points. Okay, so I'm going to take out my distance formula, which you don't need to have memorized. The distance formula is usually given. And the distance formula says x sub 2 minus x sub 1 all squared plus y sub 2 minus y sub 1 all squared. So I'm going to call my first point, I'm going to call here my first point negative 2, 5. I'll call that x1, y1. And I'll call n, point n, x2, y2. Okay. So all I have to do now is just say, well, my x2 is negative 4, my x1 is negative 2. So all I need to do is say the square root of negative 4 minus negative 2, and that's all squared though, plus -1 minus 5 all squared. And those are my y values. So the first one was the x values, and the second one was the y values. And now I have the square root of -4 plus 2 is -2. And when I square that, it's going to go to 4. And it's going to be -1 minus 5 goes to -6, and we square that as well. So that my answer here will go to -2 squared is 4, and -6 squared is 36. So it's 4 plus 36, which gives me root 40, and that is nothing more than 2 root 10. So the distance between these 2 points is 2 root 10, or approximately 6 point something. Okay, which is going to be greater than, the length is going to be bigger than 6, definitely, because it's greater than the other 2 sides, since it's our hypotenuse. All right, let's try another point. So we'll do, well, again, we'll write down our distance formula. I keep forgetting to, oops. Okay, so we write down our distance formula, and that's going to be our change in the x's. And it doesn't matter which one I put first, plus our change in the y's, because everything gets squared anyway, and our change in our y's, and it's summed up to our change in the y's. And we're going to say that the change in the x's, I'll say that it's 11 minus 3, and that all goes squared, plus our change in our y's, which is -1 minus 9, all squared. So we end up with the square root of 11 minus 3 is 8 squared, and then -1 minus 9 gives us -10 all squared, so that we have 64, the square root of 64 plus 100, and that tells us that we have the square root of 164. So that'll be approximately, it's going to be more than 12, because 12 squared gives us 144. So it's less than 13 though, because 13 squared is 169. So it's going to be approximately 12 point something. Okay, I'm not going to work it out. Well, I could work it out, I guess. It would be root 4 times root 4 times root 41, so it's root 41, and therefore this would go to 2 root 41, and 2 root 41 is going to be approximately 12 point something. All right, so just before we finish off, I just want to do a quick review of the different types of triangles. Now, we have scalene triangles. Remember that the types of triangles are either scalene, isosceles, or equilateral, and then of course we have right triangles. So a scalene triangle has all 3 sides that are different lengths, and if all 3 sides are different lengths, all 3 angles are going to be different as well. Then we have isosceles triangles that tell us that if we have 2 sides that are equal in length, and the third one is different, the 2 sides that are equal in length also have 2 angles that are equal. So I've shown that with the 2 sides here in blue, and then the 2 red dots showing that those are the angles that are equal to each other. And then we have the equilateral triangle. The equilateral triangle has all sides that are equal in length, and that means that all angles are also equal in length. They are going to be 60, 60, and 60, since the total number, the measure of the angles is 180. I will take 180 degrees and divide that by 3, because there are 3 angles, and we know that each angle is going to be 60, and all 3 sides are the same length. And then we have the right triangle that has one 90-degree triangle, which is opposite the hypotenuse. Therefore, it is the largest angle opposite the longest side. And then we have the 2 legs of the 90-degree triangle. Okay, let's go over possibly one more question, maybe 2. And the question says, suppose we want to prove that a triangle is right-angled, isosceles, equilateral, or scalene. How could we do that by using the distance formula? Okay, so we could use the distance formula. Let's take example C, we could use the distance formula to classify triangle ABC as either equilateral, isosceles, or scalene. And all I would have to do is use the distance formula 3 times. So I would have to compare AB. So I would have to find the distance between AB. I would have to find the distance between AC. And I would have to find the distance between BC. And if all 3 of those lengths were the same, then I would know that it's an equilateral triangle. If 2 of those sides are the same length, then it would be isosceles. And if none of the sides are the same, then that means that it would be scalene. All right, so I'm going to start using the distance formula. Again, I'm just going to place the distance formula up here, d equals, and I'll write it as the change in the x's, all squared, plus the change in the y's, all squared, and I take the square root of that so that I will get, doing AB first, I'm going to do the change in the x's, so it'll be -1 minus 2, so I'll do -1 minus 2, all squared, plus, and then I'll do my change in the y's, 0 minus minus 2, all squared, and that'll give me the square root of -1 minus 2 is -3 squared, and then 0 minus minus 2 goes to 2 squared, plus 2 all squared, so that I get the square root of 9 plus 4, and that'll give me the square root of 13. And I'm just going to leave that as the root 13. Now I'm going to find the distance between AC. So I'm doing AC now. So I'll take the square root of, and I'll do -1 minus 4 all squared, plus 0 minus 1 all squared. And that's going to give me the square root of -5 all squared plus -1 all squared, so that I end up getting the square root of 25 plus 1, which is 26. So I have root 26 as the length of AC, so I know it's definitely not equilateral. And then I'm going to find the last length, BC. So BC, I will say it's the square root of 2 minus 4, the change in the x's, plus -2 minus 1 all squared, and that tells me that I've got the square root of -2 all squared plus -3 squared, and that gives me the square root of 4 plus 9, which is equal to root 13. So because we have root 13 at AB, we've got root 13 at BC, and AC is equal to root 26. 2 sides are the same length, and therefore this must be an isosceles triangle because 2 sides are the same length. So, you know, go back and look it up if you don't remember what the difference is between isosceles, equilateral, and scalene. It's important that you know them now, and also a right angle triangle. All right, last question is, now if we have normally had the points, okay, and we were given 2 points and we had to find the distance between them, so what we can be given now is that we know what the distance is between the 2 points. So maybe I know that a point is here at P, 2, 3, and I know that the other point is found at something and -1. So it's somewhere and -1. It could be in the positive or in the negative, I don't know, but it's at -1. Okay? And we know that there's 4 units apart. So we know the distance. The distance is given to us as being 4. So what we would do is we would say, okay, well, my distance formula is still the change in the x's. So it's x2 minus x1 all squared plus y sub 2 minus y sub 1 all squared. And then we could say, well, how about we insert the values that we know? So I know that in point P here, my value of the x is a 2 minus a. So a is the next point here, and it's all squared, plus 3 minus -1 all squared. And the distance is 4. Okay. Now, what we can do is we are going to simplify what's underneath here, but we're only going to simplify. We're not going to FOIL the 2 minus a all squared, okay, because that's just going to complicate things further. But I can simplify 3 minus minus 1 all squared to 4 squared, which is 16. All right, so I now have 4 equals the square root of 2 minus a all squared plus 16. So what I can do is, to get rid of that square root, I could take the square root, I could square, not square root, I could square both sides. Squaring both sides means that I am doing the opposite operation of square rooting. So if I square one side, I'm going to square 4 squared, and that goes to 16. And that's going to end up giving me 2 minus a all squared plus 16. I simply got rid of the square root sign. I did nothing more in squaring the whole thing. It doesn't affect what's underneath. It's just going to affect the square root. Okay, so now all I need to do is bring the 16 over to the other side. So 16 minus 16, we're just going to solve for a now. 16 minus 16 is equal to 2 minus a all squared, and 0 is equal to 2 minus a all squared. Now if I take the square root, opposite operation, I take the square root of 0 and the square root of 2 minus a, I end up getting that 0 is equal to 2 minus a. And in simplifying that last step, then we have that a is equal to 2. So that means that the point is going to have to be 2 for the value of the a and negative 1. So looking at our graph, if we were to graph this point, this is what it would look like. This is what the graph would look like. We would have point P found at 2 and 3. So there's point P, 2 at 3, which was given to us. And our new line is going to be 2, 1, 2, and negative 1. Okay, that's not 2 and negative 1. 2 and 3. And the other point is going to be at 2 and negative 1. 2 and negative 1. Okay, so that means that our distance will be 4 units. And it makes sense. 3 minus 1 takes us to 4. You understand that this line could have been anywhere here, that it was 4 units apart. It could have been anywhere on this graph. It happened to be, though, a vertical graph. All right, a vertical line, rather, not a vertical graph. All right, I'm done. Your homework or your classwork, we'll see, is here, and it will also be found on PowerSchool. See you next time.